So students, this is the second video class on design philosophy, structural designing first subject. So far we have discussed about two earlier design philosophies. One is the ultimate working stress method, then ultimate load method. So there are a lot of many drawbacks for these two methods. So the latest method that we are using nowadays, it is the limit state method of design. Limit state method of design uh, was introduced in was completely introduced in India from 2000. That is why the code IS 456 2000 is the limit state method of design. Now, the limit state method is an advancement over the traditional design method. It is the plastic design method. It is a plastic design method. There is a reason because we are not taking only the elastic region, we are taking the plastic region also for the design. That means for a steel of grade Fe 500, the elastic region may be up to only a 200 Newton per mm square, only maybe. So we are taking the plastic stage also. That is we are assuming that the steel can carry some more load, so that will result in the economical design. Now, in this method give a comprehension and rational solution to different problems. Unlike working stress method, the working stress method is based on the calculation of working stress of a material only. And ultimate load method, it is based on the calculation of ultimate load condition. That is, this working stress method was only based on the calculation of working stress of the material. Ultimate load is based only on the ultimate load alone. So both the conditions were, both the methods were only for consider was used in only one context, considering only one factor. But in limit state method of design, it is considering safety and serviceability. That is very much important. That is limit state method of design. That is, we are designing for safety and also designing for serviceability. Safety means the given structure should be safe enough. Serviceability means there should not be excessive deflection or cracking. That is, for example, I can build a structure, build a beam in such a way that it is safe under any load. But after some cases, at some time, it will deflect, but it will not fail. That is safety. So serviceability means it can, the deflection is also controlled, or the cracking is also controlled. That means it, because a structure is safe means it is safe means it is able to carry any the complete load. Serviceability means it is having the durability and it is able to, that there is no excessive deflection and all. Okay, or tilting like that. So that is, both these concepts are used in limit state method of design. And in the safety, we are taking ultimate load. For the ultimate load, the safety is checked, and for serviceability, we are taking the up to the at the working load. What is in the ultimate and the working load? Ultimate, in the case of a concrete, the ultimate will be, if F20, the ultimate stress will be F20. And for serviceability means working load means divided by the factor of safety, or divided by the any other divided by the some factor. Okay, that is working load. So in short, limit state method of design, it is considering of two types. One is considering safety. For safety, we are taking up to ultimate. Then one is considering serviceability up to working load. Okay. Multiple safety factors for adequate safety and serviceability by considering limit state. Multiple safety factors are taken considering adequate safety and serviceability. Multiple safety factors means for different material, different like that it is taken. Now coming into the real limit state method of design. The limit state method of design is of two types. Okay, limit state of collapse or failure, limit state of serviceability. That is, this means that while I am designing any structure, any element of a structure, beam, column, everything, I will be designing and checking all these factors. I will be designing for all these factors and checking for all these factors. For example, limit state of collapse. It is of four types of flexure. Flexure means bending. That is, bending happens in what? In a beam. Compression in the case of a column. Shear. Shear means force. Then torsion. Torsion means rotation. Then limit test of serviceability. In serviceability, there will be deflection, cracking, vibration, fire resistance, etc. So if now while we are designing a structure, we will start by checking all these factors. For example, if I have to design a beam, so I will first find out this bending. What is the maximum bending? So how you can find out the bending? You know one equation. What is equation? Bending equation is m by ei. M by ei is f by y is equal to, that is the equation, bending equation. So from that bending equation, I can find the maximum bending moment. Then from using that bending moment, I can design. So how using the moment, how we will design, I will explain. Then I will check for torsion. Then I will check for compression, like that. Next is serviceability. I have to check for deflection, cracking, vibration, and so in all, the limit state method of design, it is of two types. Two types of limit states are there. One is limit state of collapse or failure, and the one is limit state of serviceability. In the limit state of collapse or failure, there is flexural, compression, shear, and torsion. In the state of serviceability, there is deflection, cracking, vibration, and fire resistance. Okay, so these two are the. Now I have the first slide in let me say I said about multiple safety factors. That is based on the experience, tradition, and engineering judgments. There are two types of safety factors. One is load and resistance factor design format, LRFD. Other one it is partial safety factors format. There are two formats: load and resistance factor format and partial safety factor. This means that, to be simple, these are two factor of safeties or partial safety factor. Here in working stress only we are using factor of safety. In limit state we are using partial safety factor. So partial safety factor, that is a safety factors are of two types, these two. And this load LRFD is used in load and resistance factor design format, is used in the America and US and in India we are using partial safety format. So here, limit state of method, we are using partial safety format. This will be more clear while we are discussing these. More discussions we will be able to understand. So in India, we are having partial safety factors. So partial safety factor means, that is, for a structure to be safe, the design resistance should be greater than or equal to the design load effect. Okay, that is, for a load only we are designing. For a maximum load we will be designing. So the design that is the resistance which we have obtained while designing should be greater than equal to the design load, that is a maximum load can come in a structure. So the design resistance, that means reducing material strength using partial safety factor. That is, partial safety factor is used for the material. Okay, that is, for concrete it is gamma C, for steel it is gamma S. In this load, another factor, here we are enhancing the load using a partial load safety factor. That is, for dead load gamma D, live load gamma L, this one gamma W. So what I meant is that here what is we are, I'm making the point that in the limit state method of design, there are many safety factors. Safety factor means, in the last we have told about, if a concrete of M20 is used, then what is the maximum strength we are taking for design? 0.45 FCK is taken. 20 is then 20 into 0.45 is only taken. So that is a safety factor. Okay. While in steel, what is we are taking? 0.87 Fi is taken. If 500 is the steel, only 0.87 times it is taken for the design. So that is one type of safety factor, that is partial safety factor. Now, in the case of load, I have told about lot of load, that is dead load, live load, and environmental load. In the environmental load only we are getting wind load and earthquake load. So here we are using in order to find the load. So for example, if I am designing a structure, I will be first calculating the load which can come in that structure. For example, I am having so many UDL, so many UVL and point load. I am calculating all the loads that can come in that structure at that time. Let it be 100 Newton. But I will be designing not for 100 Newton. I will be designing for a some higher value of that. And that higher value depend on the will be is known as the partial load safety factor. That is, if the maximum load which I calculated in a structure is only 100 Newton, then I for the design stage, in order to design, I will multiply that load with a factor that is known as partial load factor. So in the case of a dead load, it will be gamma D. In the case of live load, it will be gamma L, and in the case of wind or it will be gamma L. Okay, that is, if I am getting a load, I will be multiplying that load. Then only I will be deciding. That is because in some cases the load can reach up to that is reach up to a higher value. Or if I am correctly designing for 100 Newton, then due to the durability, due to some curing reasons, due to some workmanship, then there can be some decrease in the strength. But then, if I am designing for the correct one, what will happen? The load will reach and the strength might, that can cause the failure. So I have to design for a higher load. That higher load is obtained by multiplying the available load into the partial safety factor for load. Okay, so while we are designing a structure, the first step will be we have to find out the loads. So while finding out, we will always we will add all the loads. What is the dead load? What is the live load? What is the wind load, etc. Then we will apply a factor, and that factor is known as the partial safety factor for a bulk. Okay. Now this is the partial safety factors in the limit state. That is, you can see that the limit state, in the limit state there are two types, collapse and serviceability. In the limit state there are two types, collapse and serviceability. So in the there are partial safety factor for material and partial safety factor load. For material, in the collapse, we are taking partial safety factor of concrete as 1.5 and 1.15. In serviceability, we are taking as 1. That is the same strength is taken. Okay. Now, in the case of loads, the UL means the ultimate load. Ultimate load is equal to 1.5 times into dead load plus live load. This is one combination. So now I am going into one important thing. I have said that in a structure there will be lot of loads. Okay, there will be dead load, live load, wind load, etc. So according to the Indian standard, we will be designing, we will be finding out the load combination based on this table. That means these are the three combinations. First one, I will add the live load and dead load, multiply it into 1.5, will give us some value. I will design for this value. Okay. Next one, I will take another load combination, 1.5 into dead load plus live load, or 0.9 into dead load plus 1.5 into live load. This is another combination. Next combination is 1.2 into dead load, live load and WL. WL is wind load. So that I am not designing a structure for just one load. I am designing the structure for a combination of load, and the best and the most highest value or the critical value we will choose. This is the main concept of design. That is, in the design, the first step will be we will be finding all the loads. Then after finding all the loads, we will add the combination, because I cannot add For that combination, we have IS 456. And according to IS 456, we have different load combinations. That is, dead load, if we are combining dead load and live load, it should be multiplied by 1.5. Next condition is dead load and wind load. I will multiply it by 1.5 dead load into wind load, or 0.9 into dead load into 1.5 into this. Both these values are different. Then if dead load, live load and wind load are coming, there will be 1.2. Okay. So this means there are a lot of other combinations are also. So we are not designing for just one. We cannot predict, because regarding the structure, really we cannot predict what would be more. There can be wind, there cannot be wind. So we will be applying all the load combinations and finding out the most critical one. And for that most critical load, we will be designing the structure. Okay, that is important. As we are going through this class, you will understand what we are really meaning, because this is the concepts we are creating. So once we are doing a problem, or when we are coming to a problem, by the end of the first module, you will get an idea about what is the subject is, because it's a very new subject. We are using the code. There are a lot of things are there. Now next, this is a limit state of collapse. That is serviceability. The material for serviceability one and one is stable. Now the combinations you can for service, this is UL, it is the ultimate. Now here SL is a service load. Service load is equal to 1 into DL into LL, 1 into DL into everything. Then if live load, dead load and wind load is there, 1 into 0.8 into 0.8. So sometimes the wind load will not be there. What is the reason? If a building is having a height less than 10 meters, we will not take it wind load. Only the live load and dead load will be there. So this is the combination, live load combination. Okay. Now I am going to the okay. So this is the IS 456, and in IS 456, we are having at page number at the clause number 35, it is written structural design limit state method. So I am in the same video, I am showing both these video class. I am showing both this text, that is IS 456, and the explanation is given because you have to be very familiar with what are the clauses. So the IS 456, in IS 2000, the clause 35 explains whatever I have said now, because here it states, in this method, the design is based on the limit state concept. The structures designed shall withstand safely all the loads and etc. These are the limit states. Now here look, the limit state is of two types. One is the limit state due to collapse, and next one is limit state due to serviceability. Okay, the limit state to serviceability, again it is due to deflection, cracking. Then here we are having other things also, deflection, cracking, etc. Here you can say one important thing is that, look at this, the surface width of a crack should not in general exceed 0.3 mm. This is a very important factor. This is asked in many what we call many objective questions. It is asked, that is, what is the maximum permissible crack that is permitted in a concrete? Permissible crack, that is 0.3 mm is the maximum permissible crack in it, from 0.3 mm. So it's very much important. There is other conditions are also is there for the different crack width. I'm telling everything. Then next one, it is the characteristics and design value and partial safety factors. Okay. So here, if you in the question, if in the exam, you may be asked what is meant by characteristic strength of a material. Definition is given here. That is, it means the value of the strength of a material below which not more than 5% of the result are expected to fall. It is given in the. So that is the reason I have told that you must be very familiar with what is being asked in the what is there in this IS code. So from table 36 and clause 36.1 we will be getting. So you must understand. Then what is meant by characteristics load? The term characteristic load means the value of the load which has a 95% probability of not being exceeded. This is very much important. Expanding this. So the term characteristic strength means the value of the material of a strength of a material below which not more than 5% of the results are exposed to fall. The next one, it is the characteristic load. The term characteristic load means the value of which has 95% probability of not being exceeded during the lifetime. That is characteristic load. That is, this means that we will be designing a structure for the characteristic load. Last, I have given example of 100 Newton, and I have increased it into some other one by multiplying it by some factor. So that factor, that load means during the lifetime of the structure, 95% probability that load will not be exceeded. Again, if 5% is left because of what? Because there is lot of unpredicted things will be happening. For example, that is the flood happened here. So many localized flooding happened. So some structures failed, some smaller. So what would be the reason? Because we are not designing a structure. That structure was not designed for resisting such a flood. Flood is a huge force. It is a hydrostatic force. So we cannot design a structure for in such a way that it will not be destroyed at any load. We cannot build anything like that because unexpected things can happen. Therefore, that is the reason why we are using 5% is we are letting other 95% for other 95% that such a load is being taken. Okay. And here also the different clauses. This is in the last video class IS 875, IS 875 part 1, part 2, part 3, IS 18934, seismic force, etc. Now, so this I am explaining lot of things. Now the design strength of a material is given by FD. FD is equal to F by gamma M. Gamma M is the, it is given here, partial safety factor appropriate to the material and the limit state being considered. That is the thing which we explained in the slide. That is, you take the slide, look at here. That is, so the partial safety factor of a material, that is 1.15 and 1.18, 1.15 and 1.5 and 1.15 for steel. That is gamma M. That is the gamma M which is shown here. So here, so it is the gamma M. Then that is a design value. Then is the loads. Design load is equal to, look at this. Design load is equal to F into gamma F. Gamma is a partial safety factor for the load. This is the thing which I explained here. That is, look at this here. Okay, so you can see that here what I have done, it is, look at it here, the partial safety factor is divided and the load factor is multiplied. Okay, that is been done. Go back to the 456 code. That here, look, then we have the partial safety factor for various loads, or which is a table which I have explained. Look at it here. The load combination, dead load, live load, it is in limit state of collapse and limit state of serviceability. It's 1.5 into something. Then dead load plus win for 1.5 and 0.9, 1.2. This is the table. This is the original table from which the other table in the presentation was developed. So that everything is given in this table. Everything is given in IS. You must know where it is given. It's important. Okay. Then regarding the, then let me show you. These are the things which you will be able to study. Now I am then limit state is of many types. First one is flexure. Then flexure, there will be like this. These are the assumptions for a flexure. Okay. Assumptions for a flexure. So now I am giving you an assignment. This assignment you should submit by the next day after the class, by after this class, by the next day 9 a.m. Thus the question is, write down the assumptions of the limit state of collapse. You can write it directly from the IS 456. Then you have to write all the assumptions which are written here. The figure need not be drawn. You should write all the assumptions. We are having the plane section remains plane before and after bending. It is almost similar to that of the maximum strain in the concrete at the outermost fiber is taken as 0.05. This I have explained in the last class. So everything is there in this. So you have to write the assumptions and submit, and try to write it in a single page itself. Okay, so you have to write these assumptions. This is a question, you have to submit it. So I have to make clear that while we are conducting the this online class, test means that will be a Google form test that you have to submit by just clicking the link. Assignment, I am meaning by the term, it will be assignment means that is you have to write it and submit. It will not be on the same day. Okay, the next day you will have to submit it after writing. After all the class is over, after 2 p.m. The class will be over. Then you have to write it and be submitted before the. Uh, I will give the question. You have to submit it by, you know that because you have done it. Okay. So this is the one question. So so coming to our discussion, that is limit state of collapse. The limitation of collapse. In that, first one flexure is here. Then we are having limit state of collapse compression. Again for compression there is assumptions. That is in addition to the assumptions given in 13.81. That is in addition to the assumption in other one, that is 13, that is other assumption. Other assumption, the flexure, the maximum compressive strain in concrete in axial compression is taken as 0.002. This is very important, okay, and specifically mentioned because many of the job related questions this will be look at this. Maximum strain in a concrete at the outermost compression fiber is taken as 0.0035 in bending. This word is very important. In bending it is taken as 0.0035, but in the case of, look at it. Maximum compressive strain in the concrete in axial compression. What is when bending means? It is just the deflection, one direction. Compression means when we are compressing in a case of a column, like that. It is taken as 0.002. So this is mainly asked in many of your PSC examinations, or in your UPSC examinations, or in your our other central government examinations and many interviews. So maximum compression in axial force is taken as 0.002, and in bending it is taken as 0.035. Okay, now the maximum compressive strain at the highest compressive fiber, no tension, shall be 0.035 plus minus 0.07 times the strain at the least compressed extreme force. This is another condition. These are the clauses in addition to the other clause. So in examination, in your final examination, if it is a question is asked like this, write down the assumptions of limit state of method of design, limit state method of design. Then you have to write these assumptions. You can directly write this from your note itself, but the main thing is that you should not write. You should write. You should. I think that you should write an essence of that, not a completely copying in the same way. Yeah, this one is same. Plane section of the next plane before and after bending. Then you have to. You can write in your own words, because here the relation between concrete stress and you have to read this, and what is the main point, just write there. Otherwise, the main problem regarding this is that you will be asked, mainly this type of question is asked in your part B, at 6 marks now, 6 marks. So if such a question is asked, all the students will be writing, will be continuously writing everything written in the code, and your almost all the 6 mark, that your most of time will be lost in that way. So you must think that whatever given in this code, you must write an essence of that. What is a briefing of that? No need to write everything in that. Okay, that is, you must know the things. You must list what is the important point it is mentioned. Just write that and finish the question. Do not sit there and writing the same question, say every line by line from the code. That is another disadvantage of using the code, because we know that it is in this code. Therefore, we will be thinking that okay, I will be that is you should first of all read all the assumptions. And I'm not now I'm giving you have to write the assignment now. So you must read it and write the appropriate points. Okay, if you can shorten some points, then do that. That only need to be done. No need to write line by line or word by word. And that is not the thing which is meant by asking such a question. That is, if you are given a code and if such a question, it doesn't mean copying that. You must know that, you must read it, and what is the essence. So before that, so you must know it. But the reason is that you must not by heart it. And in the case of any competitive exam, you must note the points. That is, for example, which I have tell now, this point 0.135 or point 0.112 like that. So, limitations of flexure we have discussed. Limitation of there is compression. Another limitation of collapse is where it is limit state of collapse. Compression is there. That is the second one. Next one it is all other things. Some of the things we will be studying. Then is this limit state of collapse in that shear. Okay, shear. This I will take in the class when the problem is coming. I will be explaining. That will be the best thing. So then only you will be remembering why I am using these tables are very important. We will be using these tables for the design. Next one it is look limit state for collapse torsion. Okay, these are the four limit states of collapse. Okay, there is compression, there is flexure or bend. Flexure means bending. Then for compression, then for another limit state was for shear, then for torsion. Okay, so that is limit state method of design is divided by two. What is that? Limit state of collapse and limit state of serviceability. In collapse, there are four conditions. That is, while designing a structure, we have to check all these conditions. Then at last only structure will be perfectly designed. Okay. Next one, it is the limit state of serviceability. Okay, look at it. Limit state of serviceability. In that first one, deflection. Deflection for a flexural member. Flexural member means bending. Then, then, then limit state of serviceability for a cracking. Okay. For so this is the limit state of serviceability. So this was the thing which I explained in the slides. Okay. So let us go back to the slide. Let's go back to the slide. So for ending this class, I am just summing up everything. Since there is a switching of this PPT and other um, PDF, there is some lag in time. So bear with me. So this was the class this class we started from here. That is limit state method. The limit state method is the most advanced method. It is a plastic method. Here we are using two conditions, safety and serviceability. For safety we are taking up to ultimate load. Serviceability we are considering the working load. Then for limit state there are two types of limit types. That is limit state of collapse or failure and limit state of serviceability. In the limit state of collapse or failure there is flexure, compression, shear and torsion. Then limit state of serviceability there is deflection, cracking, vibration, fire resistance, etc. So I have said that it is mainly shown in the clause 35 following 35, that is like that in that range only. It is the thing is the NIS for it is given. Then about the partial safety factor. Partial safety factor is of two types. Again, that is written for the material and for the load. For the material, again it is again divided into there are two types of limit state, collapse and serviceability. In the type of collapse, the partial safety factor is different, and for another is different. For serviceability, again it is different, and then for steel. Then for the loads, it is given in the. So with this, I am ending this class. So the next class we will have a discussion about the difference between working stress and limit state method. That's all. Thank you.